Hey everyone, my name is Ronak back with another video, and in this video you are going to learn about the recursion. This is the 6th video in the series of the interview preparation data structures and algorithms using Python. So I would say today's video is way too much important because we are going to cover something known as recursion. So recursion is an, I would say, way too important concept because this, I would say, is foundation for many algorithms. So for backtracking, then graph traversals, and I would say tree traversals. So usually there are two ways with which you can write a code. One is iterative, which uses loops, okay, for while, something like this. And then there is recursive, which uses the function in subfunctions like this. Okay, so we will now understand the recursion in depth. So we will take a lot of problems. We will actually solve them using the whiteboard example, and I'll also write some code in the Python. So essentially the recursion calls itself unless a condition is met. So practically this condition is known as base condition, and it will only stop when that base condition is met. So we will now try to focus on the basics of how you can make a recursive call. So if we look at the importance of the recursion practically can help you basically write less code. If I can get rid of a long while loop or for loop, it is very good. Second thing, it makes your code look more professional. So if you solve anything that can be solved using recursion in, let's say, any interview, you will get more weightage, trust me. And the concept of the recursion only justifies that you have a deeper understanding of how the elimination of the function works. So for that, there is a prerequisite which I should have covered earlier, which is stack data structure. And this is way, I would say, more essential in order to understand the recursion. So it is essentially like this. So you can insert an element which will stay on the top. So that operation is known as push, and you can remove the element which is on the top. So if I want to remove an element that is over here, I would have to remove every single element first, and then only I can remove this one. So this is known as the stack, which is essentially LIFO, last in first out. And this is very important data structure in order to learn recursion. But there are very less problems, I would say, that I have myself encountered of this stack. There is much more likely chance of getting, let's say, a binary tree or a linked list way more than a stack or in queue question. So that was the only reason I decided that let us first cover what things are important, and later on, if there is time, I can make some single video for stack. Okay, but just understand this, that the push and pop option is the way the stack is being used. Okay, so if you want to insert anything, it will always stay on the top, and if you want to remove, first element to pop out of the stack will be the element that inserted the last. So that is about the stack. So let us start with our first recursive program, that is essentially finding a factorial. Okay, so factorial essentially is, let's say if I say 6 factorial, it is essentially 6 into 5 into 4 into 3 into 2 into 1. So this is, I think, 720. Okay, so if I say 5 factorial, it is 5 into 4, 20, 20 into 3, 60, 60 into 2, 120, 120 into 1. Okay, so this is 120. So this is the way it works, and always the factorial of 0 is equal to 1. Okay, factorial of 0. So let us now write a recursive program for it. So first I will write a program, and then I will show you how it works. So let's say factorial. Okay, and here you will feed it a number. Then you will return the function, let's say with n, into the factorial of n minus 1. Okay, so deduction will happen in this function itself, and you will require a base condition. So if n is equal to 0, I would return 1. Now this is the amount of code you will have to write for just calculating the factorial. Seems pretty, I would say, confusing for a fresher, for a beginner, but this is the way it is. So let us now take this example of the 5 factorial itself. Okay, so it starts with fact of phi, and it checks, okay, if phi is equal to 0, no. So we now return this. So I would return n, which is phi, into fact of 4. But now this call does not end over here, because we have again called a function. So now this goes over here. If 4 is equal to 0, no. So I would return 4 into fact of n minus 1, which is 3. Again this stays pending. Okay, this is not been actually executed. It is pending. It is pending in the stack. I will show you how. Again this factorial now starts to work, because this is an entire function. Okay, I can say def. It is essentially a function. Okay, it is essentially a function. Okay, now again it starts. So if 3 is equal to 0, no. So I would again return 3 into factorial of 2. One more time it gets executed. Factorial of, so you will check for the condition. So if 2 is equal to 0, no. So I would return 2 into factorial of 1. Again it goes inside it. If 1 is equal to 0, no. This does not get executed. So I would return 1 into factorial of 0. Okay, so it keeps recurring. Okay, it is always interlinked, and it is stored in the stack memory until and unless it gets executed. That is the beauty of this equation. And over here right now this gets executed. So if 0 is equal to 0, yes, it is executed. So I return 1. I return 1. So now this function exhibits the value as 1. Okay, so this 1 goes over here, and now this function is essentially 1 into 1, because the 1 over here and it is multiplied with the 1 over here. So this is 1. So this now starts getting popped out of the stack. So first this gets popped out, then 1 into 1. Okay, so the return value of this factorial 0 function is 1. So 1 to 1 we get 1. So now fact 1 is again 1. It gets popped out. So now it is 2 to 1 for factorial 2. Okay, then it moves over here. We get 2 into 1. So now 3 into 2 into 1. This gets popped out. So we get 3 into 2 into 1, which is 6. So factorial 3 is 6. It gets again popped out. Okay, so 4 into 6. We get 24. It goes over here, 24. So factorial 4 is 24. It again gets popped out. And then we have 24 into 5, which is 120. Okay, so this is the way it works. And finally, this function gets popped out. So assume this as a stack blocks. Okay, so last in, first one. So assume this as all the stack blocks. And this is for factorial 4. And one of them, so each and every time I invoke the function, it pushes into the stack. And when the function is completely executed, it pop out of the stack. So this is the way the factorial is calculated. Okay, now let us write some code for it. So I made a file name as fact.py. So we start with the function. So def, let's say, of factorial, and it takes n. Okay, and then we return n into essentially the factorial n minus 1. But we have to provide the best condition again, otherwise it is going to go beyond 0. Okay, so if n is equal to 0, I return 1. That's it. As simple as that. So if name is equal to main, we invoke that function. Okay, so I'll say outcome, or I can say fact is equal to factorial of, let's say, 5, and let us print fact. That's it, as simple as that. Now run this, it's 20. Okay, so this is the way it is executed. So this is the beauty of recursion. You will have to understand the concept of stack way too much in depth, and this will actually enforce you to work with it. In beginning it might seem difficult, but my suggestion is that please derive it on the pen and paper. Okay, once again I'm saying, I myself have committed this mistake. Earlier I was thinking that this is some rubbish thing, that you don't require pen and paper if you can compute it using your brain, but it is not possible. Okay, so you can now calculate any kind of numerical. So now let us write a program. Let me use a different pen. So let's write a program to reverse an array. Reverse an array. So how to do it? Let's say you have 1, 2, 3, 4 and 5 elements essentially, okay, in the array. The best way a naive developer would do is using 2 for loops, which is good, but it is rough and square. You have to optimize this. So we use 2 pointers. So 2 pointer solution will be, you will have a left and right, and every time you will swap, and once the left pointer is greater than the right pointer, we return the function. As simple as that. So let us write some code for this. So this actually would work in order of n. It is a linear function. Okay, so let us write code for it. So let's say reverse an array. Okay, so the 2 pointer solution. So df 2 pointers. So this will take the input array, then it will take a left pointer and a right pointer. And as simple as that, we have worked on 2 pointers earlier. While left is less than the right pointer, I will just make the swaps. So I'll say left and I'll swap the elements. So input array of the right is equal to essentially the input array of right with the input array of left. So in Python it is good that you can skip on the temp variable. Okay, so we now swap the elements, and now obviously I'll say left plus 1 and right minus 1. That's it. Okay, so if name is equal to main, I'll say array is equal to 1, 2, 3, 4 and 5, and let's say 2 pointers. We will give it the array. We will say left is equal to 0, and we will say length of the array minus 1. That is my right, and I'll now print the array. That's it. So if I run this, it is reverse. Okay, 5, 4, 3, 2, 1. So this is the way it works. Now let us look the recursive function for it. So we will now cover this 2 pointer solution into a recursive function. So let us say there is a function reverse which takes left and right pointer. So we will say, if essentially as a base condition, if left is greater than right, I'm going to return it. That's it. It ends the function. It breaks the recursion. Otherwise, I'll let's say update, like I'll swap. Okay, so left and array of, I would say right over here, is equal to array of right swapped with array of left. And I will recall this function. Okay, so reverse of left plus 1 and right minus 1. Right minus 1. Okay, now let us trace this function with an example. The way it works. Okay, so let me just take it over here. Yeah. So this is my array. Let's 1, 2, 3, 4 and 5. After reversal, it should be 5, 4, 3, 2, 1. Okay. So it starts from here. Okay, so left is on the 0 and this is on the fourth position of the array, the right, essentially your right. Okay, so first the function is invoked with 0 and 4. So is left greater than right? At the moment, no. So I swap the elements. Okay, so swapping is done essentially. So this comes over here, this goes over here. So the new array will be I, 2, 3, 4 and 1. And then I invoke the reverse function again. So now this function says 1 plus right is subtracted by 3. Okay, so again this invokes is left, which is 1, greater than 3. No. So I swap the elements. So it is over here and over here. So now the updated array becomes 5, 4, 3, 2 and 1. Okay, so essentially it is reversed. And now again I'll go over here and I'll say I will invoke the function. So it is 2 and 2. So now is left greater than the right? Yes. Okay, so those both of them are at the same point. So now this pops it out of the stack. It goes over here, pops it out of stack. It goes over here, pops it out of stack. Okay, so this is the way it works. So assume these are the stacks. So every single time it pops it out and we get the output. Now let us write some code for this. So I'll write it over here itself. So I'll say diff function reverse, let's say array, takes an input array with the left and right. So I'll say as the best condition, if left is greater than right, I'll return. Okay, so it's essentially ending it. Otherwise, I'll reverse the array with the input array. Okay, so we will have to swap. Okay, so let us just copy this. Okay, so swapping happens and over here it takes let's say input array with the left of +1 and right of -1. Okay, so now let me make a change over here. So this becomes now reverse array. And now let us run this. Answer is exactly the same. Okay, so this is the way it works. Okay, so essentially I took a 2-pointer solution that was an iterative one working with the while loop. I converted it to the typical function, recursive function essentially. Okay, so this is the way it works. Way too much simple. Okay, so initially it might seem difficult, but this is the basic foundation for all the upcoming videos. It will take a lot of time. We will work on recursion over and over again, because when you will come across backtracking, the inquins problem, the subset problem, the graph traversals, which are essentially depth first search, breadth first search, all the traversals in the tree, all the traversals in the linked list, you will require recursion every single time. So you need to solidify the concept of the recursion. Now let us take a very different example that will enforce you. So I would say this actually is a program from the GATE exam. So those who don't know, GATE is the graduation aptitude test for engineering. Okay, so I would say this is a very difficult form of examination that tests your core basics of computer science. Okay, so I am from the CS background. Okay, I have done my engineering in information technology, which is the closest branch to computer science, and this tests all of your basic core computer science concepts. So this was a very I would say great question. Okay, so they have given this function in the C. So they had say f of the star, which is the pointer array with the n element. So they say if the n is greater than or is lesser than or equal to 0, they return 0. Okay, return 0. Else if they say if the current position element in the array is modulo of 2, which is essentially even. If it is even, in such a scenario, they are going to return let's say the current position of the array plus the function once again with the next position of array, which is array plus 1 and n minus 1. Else, if it is not an even number, in such a scenario they are going to say return star of array minus the function, okay, which is star of array plus 1 with the n minus 1. Okay, so very beautiful question to check all your concepts at once. Okay, so this was a 2 marks question in the GATE exam. GATE exam is popular in India. Okay, so if any of the audience, my audience is there, so this is a good way to test your skills. Okay, this examination. Now let us, and in the end they have given a main function. So we will first solve this and then we will code this in the Python. Okay, so this will solidify your recursion. So they have given the array as I think 12, then there is 7, 13, 4, 11 and 6. Okay, so these are the amount of the examples, and they have said is 6. Okay, and then they call the function. So they say f, and they have given the star array, which is pointer basically with 6. So let us now solve this. So take a moment, pause yourself and try to solve this. Okay, obviously I will give you the solution of it. Okay, very beautiful question. Okay, this will actually enforce you to think a lot in depth. So let us now draw an array over here, okay, which is 12, 7, 13, 4, 11 and 6. And let us now try to solve this. So the first element in the array, which is 12, along with 6. This is where your case starts. So it will say if 6 is lesser than or equal to 0. No. Then it says else if 12 modulo 2 is equal to 0. Yes, this is an even number. So I would return, in this case, 12 plus the function, which is next element in my array. Okay, plus 1. So this becomes 7 and n minus 1, which is 5. So a new function has been invoked. So this stays in the stack. Okay, it has been inserted in the stack. So in my stack, if I say like this, here now there is f of 12 of 6. It is not popped. Okay, it is not popped. It will stay in the stack until entire execution gets completed, and then we start popping it one by one. So now here it will say 5, it is less than or equal to 0. No. Then else if 7 is an even number. So 7 modulo 2. Okay, 7 modulo 2 is equal to 0. No. So I go to the third condition, which is else. I would say return 7 minus the f of essentially the next element, which is 13, and the n gets decremented, so 4. So 13 and 4. Okay, so this is the way it works. And now this function is running in my stack. Okay, 7 comma 5. It is not popped till now. So this is the way it works. Now let us again do this. So this now goes, it will say if the 4 is less than or equal to 0. No. So now I'll say else if 13 is even. So 13 modulo 2 is equal to 0. No. So I will go to the third condition, which is essentially return 13, and then I would say minus. It moves on to the next element of my array, which is essentially I think it was 4. Okay, so f of 4 comma, there is a decrement, so 4 comma 3. So now the f of 13 comma 4 is in the stack pending. It is not executed yet. Again there is an execution. So it will say, okay, is 3 less than or equal to 0? No. Else if 4 modulo 2 is equal to 0, yes, this has been invoked. So I'll say return 4 plus f of the next element, which is 11, and 11 comma 2. So again in my stack, the f comma 4 comma 3 essentially is in the stack. It is in the stack memory. Okay, once again there is an invocation. So here now this function gets executed. If 2, so if 2 is less than or equal to 0, no. Else if 11 modulo 2 is equal to 0, no. Else I return the condition, which is essentially 11 minus the function, and it moves on to the next element in the array, which is essentially 6 comma 1. Okay, so again in my stack memory, the f11 comma 2 is pending. It is not been popped as such. Now again there is an execution. So is 1 less than or equal to 0? No. Else if 6 modulo 2 is equal to 0. Yes, this has been executed. Such a case, I invoke the function. I'll say return 6 plus f of 0, because there is no more elements left, 0 and 0 over here. Now again in my stack, the 6 comma 1 is pending, 6 comma 1 function. Now this is where this now starts executing. So if n, which is 0, is less than or equal to 0, yes, it has been executed. So I return it. I return 0. So the now value of this is 0. Okay, so this gets popped off. Okay, and here it says 6 plus 0. 6 plus 0, which is 6 for f of 6 of. Okay, so the popping starts. So now this element pops in the stack. Now it says over here, it comes over here, 11 minus 6, which is 5. Okay, so 11 and 2, the function of 11 and 2 is essentially 5. So I again pop 11 comma 2. Now since this is popped, this becomes 4 plus 5, which is equal to 9. So function of 4 comma 3 is 9. This gets popped out of the memory. Since this is popped off, it now says over here 13 minus 9, which is 4. So function of 13 comma 4 is 4. And over here it says 7 minus 4, which is 3. So now this also pops off. And this is now 12 plus 3. So the final one, which was pending in our stack, is essentially 12 plus 3, which is 15. This is the answer. Okay, so now this finally gets popped off. So this is the way it works. I hope you might have understood it. I would recommend every single one of you to draw this by your hand. Okay, draw this function. We actually maintained a stack now, but you can imagine this as the stack, and each and a single element started popping one by one as they were inserting. The push and pop was happening inside it. Okay, so now let us write some code for this. So let's say random question. Okay, so this is a GATE question. Let us take GATE question itself, gatequest.py. Okay, so let us write some code for this. So let's say GATE quest, or let's say f itself, the way they have said it. It will take an input array, and let's say along with that it will require an I and n. Okay, so we don't have pointers in the Python like we do in the C, and it actually returns us an integer. So it will return us an int. So the base condition is if n is less than or equal to 0, we essentially return. Okay, so this is the base condition where it actually ends. Else if, okay, so else if the input array, okay, so this is the even function. So I would say array of I is modulo with the 2 is equal to 0. In the scenario, I would say return array of I plus it invokes the function which is f array along with I plus 1, which is the next element in the array, and n minus 1. And finally we will have else. It is going to be return array of I minus the function which takes your input array with the next element as well as n is decremented. Yes, so we have it. Now let us write some code for this. Let us test this. We will test it with our same example. So we will say array was essentially first element was 12, then we had 7, then we had 13, 4, 11, and finally we had 6, and n was also 6. So now I'll say outcome is f of array with I starting from 0 and n was essentially 6. So I'll just print the outcome. Okay, so now let's run this. It runs, it gives us 15. Okay, let us run it again. It gives us 15. Okay, so this is the way it works. So any type of question you can tackle using the recursion. So this was the basic concept of the recursion. So we had solved it in extreme detail and depth. I don't think now anyone will have any issues with it. Okay, so first we actually saw the factorial program, then we wrote a program to reverse an array, and finally one gate question. So this is the way it works. And we also coded that C oriented gate question in the Python, which is, I would say, very good for your basic understanding. Okay, so if you have any questions, you can drop in the comments below, and you will find all of this material, the whiteboard stuff, as well as all the codes in the GitHub repository link below. And if you want to learn Python, you can check the other playlists too. I have a lot of stuff. Okay, so I hope you might have learned something or the other, and we will go way too much with the recursion in the upcoming videos. Okay, so we will be using recursion all the time. So this was a very, I would say, necessary algorithm. After sliding window, I was thinking of the cadence algorithm, but it's fine. I went with the recursion because it is also as important as sliding window. So yes, so this is it about the basic concept. So if you like my content, please do subscribe to my YouTube channel, and please share it with the others and your friends, and also help them learn the basic concepts of the data structures. Okay, and the language I'm using Python. So essentially this code was in the C. Okay, so the GATE exam enforces everyone to work with C, but we actually converted it into Python. So it was seamless. Okay, so this is the way it works. So I hope you might have learned something or the other. So till next time, I'll see you in the next video. So thanks for watching. Goodbye.